Hello friends, welcome to Engineering at Movement channel. In this lecture, we will study about viscosity of fluids. What is viscosity of fluids? What is practical importance of viscosity of fluids and how viscosity of fluids is important for engineering. So be connected to Engineering at Movement channel. Viscosity is a resistance, just like friction is a resistance. Samely, viscosity is a resistance, and the definition is the resistance offered to a layer of fluid when it moves over another layer of fluid. Means when fluid is in motion, one layer of fluid offers a resistance to another layer of fluid due to motion, and that resistance is viscosity. You can also call it dynamic viscosity. In this diagram we will get to know how fluid is moving, and we'll go to the formula after that. The lowest line is showing fixed surface and it is black in color, and the dotted blue line is fluid, and the upper line, which is blue in color and is not dotted, it is complete, is also surface of fluid. So it is surface of fluid. So as we move from fixed surface to the surface of fluid, the velocity of fluid will increase because the fixed surface is stationary. So we can assume that the fluid in contact with the fixed surface is also stationary, and so we will assume the velocity here 0, and velocity of the fluid at the surface, that is at the blue line, that is blue complete line, is maximum. So u is equal to max here, and we will assume the height of fluid as y. As fluid is as velocity is increasing from fixed surface to the surface of fluid, so we are showing the velocity curve as an arc. And for a dy change in height, we can assume that velocity increases from u to u plus du. As one surface of fluid is offering resistance to another surface of fluid, and that resistance is tangential, so a shear stress will be developed between the two adjacent surface of fluids, and that shear stress will keep on increasing as we will keep on changing as we move from fixed surface to fluid surface, and the rate of shear stress will be directly proportional to velocity gradient, that is du by dy. So tau is directly proportional to du by dy. If we remove this proportionality sign, we will place a constant here, and that constant is mu. It is also called constant of proportionality or dynamic viscosity. So the viscosity we are talking about is mu here. Its unit is Newton second per meter square. It also has another unit, that is poise, and 1 poise is equal to 0.1 Newton second per meter square, or 1 by 10 Newton second per meter square. For thick fluids, viscosity is more, and for thin fluids, viscosity is less. This is due to the reason that thick fluids offer more resistance during the flow, and thin fluids offer less resistance during the flow. And now we come up to the physical significance of viscosity. As we know that the greater a lubricant viscosity, the greater pressure or load it can withstand. So viscosity is important as the fluid stands pressure and loads, and it is used to maintain a separation between the moving parts of a machinery. Take for example, you are putting engine oil in engine, and engine oil is placed into the engine because as the engine has moving parts, so a high temperature is developed between them. So to withstand that high temperature and to make a separation between the moving parts of engine oil is important. And for every engine there is a engine oil with a appropriate viscosity. So while selecting a engine oil, we have to think about its viscosity. If it is within the specification, then only we can use that engine oil. So here the viscosity comes into the role. But there are limits to this relationship. If the viscosity is too high, then it won't flow readily. The fluid won't flow readily, and your engine will work harder, and it will consume more power, and then your fuel efficiency will decrease because your fuel will burn more. So viscosity has appropriate specifications according to its application. According to application, there is a particular specification of viscosity. In manufacturing industries, when there is an inspection of oils, in most of the cases viscosity is inspected, and when it passes the specification parameters, then only fluid is okay from the quality control department and it can be used further. So friends, viscosity has a vital role in our engineering applications. I hope friends you all have enjoyed this lecture, and at Engineering at Movement channel we will be bringing more lectures like this. So do subscribe our channel and like and share our videos. Thank you.